Hi, my name is Aryan Poddar. This is my lab report for Physics 2211 at Georgia Tech. This lab investigates constant velocity using the motion of a trolley. I'll first state the purpose of the lab and then introduce the system and its surroundings while explaining key concepts such as Newton's second law. I'll then analyze the trolley's motion using a tracker software and create a computational model based on the data collected. I'll then produce graphs using the real-time data and the computational model and compare the two. Finally, I'll answer some essential questions. The purpose of this experiment is to apply Newton's fundamental laws of motion in the real world. This lab focuses on Newton's second law, the momentum principle, and verifying its accuracy by comparing position time graphs created using the data collected in the real world and data produced using a simulated model. Newton's second law explains how forces acting on a system from its surrounding cause changes in the momentum of the system over time. In this experiment, the system in question is a trolley. If there's no net force acting on the system, then change in momentum is zero and the velocity will remain constant. This can be seen by the momentum update formula, which is final momentum is equal to initial momentum plus F net into delta t. Dividing the equation by mass gives us the velocity update formula, which is final velocity is equal to initial velocity plus F net over m into delta t. If there's no net force acting on the system, then F net is equal to 0, which leaves us with final velocity is equal to initial velocity, indicating there is no change in velocity and velocity remains constant. This is also supported by Newton's first law of motion, which states that an object at rest will stay at rest and an object in motion will stay in motion with the same speed and direction of travel unless the object is acted upon by an unbalanced external force. Procedure. I first recorded the motion of the trolley moving in a straight line at a constant speed. Then, I imported the video into tracker software and tracked the position of the trolley at set time intervals. I will then manipulate the starter code in CloseScript to create a computational model that mimics the trolley's motion. Next step will be to create position versus time graphs based on data collected and then comparing the two graphs and the models. I pushed the trolley from left to right so that it moved in the positive x direction and accordingly chose the axis. For this experiment, air resistance and friction were assumed to be negligible. I started tracking the position of the trolley after it lost contact with the hand, ensuring there was no external force acting on the system and the trolley moved at constant velocity. The initial position of the trolley was 0.012 meters and the initial velocity of the trolley was 0.798 meters per second. Initial velocity was calculated using the formula change in displacement over change in time for the first few frames. Next, I created a computational model using CloseScript. A ball was used to represent the trolley. I left the mass of the ball in the code unchanged as it does not affect velocity and mass cancels out in the formula. Delta t was set to 1 by 30 as the video was recorded at 30 frames per second. The initial position and the initial velocity of the ball were stored as vectors in the code. I then used position update formula and velocity update formula to map the motion of the ball as seen on the code in the right. Initially, both the graphs overlap, suggesting the computational model is a good estimate of the trolley's motion in real time. However, if we observe closely, the tracker line deviates slightly from the model. The deviation is larger at greater time intervals. The decrease in the slope of the blue line indicates a decrease in the speed and velocity of the trolley. This is due to the trolley experiencing a frictional force which acts in the opposite direction to the object's travel. Now on to some questions. I chose my axes such that left was negative and right was positive in the x direction, resulting in an upward sloping curve. Had we flipped the axis, the only difference would be that we would obtain a downward sloping curve with the same conclusion that the computational model overestimated at greater time intervals, suggesting the presence of a frictional force. This also indicates that there's an unbalanced force acting on the system and the assumption of net force equal to 0 was not entirely accurate. Lastly, it is impossible to tell how many forces add to give net force equal to 0 as the trolley also collides with air particles that contribute to resistive forces. This lab can be improved by using a surface with very low dynamic friction coefficient or accounting for the frictional forces in the model.